Hi everyone, it's me again, and this is another lesson on Three.js for beginners. The topic for today is cameras. We will be using our previous setup, so I'm just going to add a few lines of code to what we've already created. Since you already have a setup, I will not be creating that all over again. So I just want to mainly focus on the properties of our cameras. We already have a perspective camera in our scene. That's what we've been using all along. So next I will create an orthographic camera and I will create some variables which will make it a lot easier to work with some of the properties or values. So I think we should just start. What I'm going to do first is add some variables here. I just created a perscam width, perscam height. What this is just the perspective camera width and perspective camera height. This is the same value that we're using here. I'm just gonna make this small a bit so that you can see it better. Okay, so it is basically this value over here. So I just assign that to this variable, and then I just created an orthographic camera width and orthographic camera height. Now this will be the values that I will use for our orthographic camera. So next what I need to do is then add our orthographic camera. So here is our orthographic camera, and in here I'm using the orthographic camera width divided by orthographic camera divider. Just copy the orthographic camera divider over here, and there it is. So our orthographic camera divider is 100. So that's what I'm doing just here. I'm just taking the width and I'm dividing it by this value over here. So that's what that is. So this is a typical setup for an orthographic camera. So you'll say orthographic camera width, and then you will divide it by minus orthographic camera divider, and then here you will repeat the same process, but here you will divide it by a positive camera divider value. Same for the height, you will repeat the same process but a bit different. So you just do this exactly as I did here in my code, and then the near clip plane will be 1 and the far clip plane will be 1000. So these are the important values that you've got to have. Okay, so pay attention to that. And we're going to go to our render function, and in here we're going to need to make some changes. So we're going to change these values. We're going to add some new values. So I'll just go through them. We're going to say render. We're going to first start with renderer.setPixelRatio. So before we render anything, we're going to call that function, and then we'll have our cube rotation or not. That's not a necessity, but I'll just have it anyway. And then here we will call the update projection matrix for our orthographic camera, and then we will set where our orthographic camera is going to look. So it's going to be centered, it's going to focus on the scene's position, which is at 0 position. Then here I will set the viewport settings. Because we want to have both cameras rendering side by side, basically I'm going to be using half of the camera's width for each camera. So these settings are to set up where each camera is going to be rendering. So according to this setup, our orthographic camera is going to be rendering on the left half of our canvas, and over here this is going to be rendering on the right half of our canvas. So these are the settings. Set viewport. So we're gonna divide the width by 2, and then for set scissor we just repeat the same process. We just take the same values and put them into this method, and then set scissor test to true. Then after that, then we render our scene and orthographic camera. And so next we set the camera aspect ratio. So we will divide that also by 2, only the width, because we're just only cutting the width by half. The height will remain the same. And then we'll set up the camera projection matrix, and then we'll set up the camera look at. So this is the perspective camera, by the way. So that will be also focused on the 0 position, which is where the scene position is located. And then we will set up another half of the renderer. So this will be the right side. That's where the perspective camera will be rendering. So we just set that for the viewport, and then set scissors, also set scissor test to true, and then render our scene with our perspective camera. Okay, so that should be simple enough. So now we're gonna go to our browser. I'm already running my server, so you can run your server so that you can be able to see the code running on your browser. Okay, so there we go. I'm just going to add a light in here so we can see. Okay, so this is what our setup looks like. This is our orthographic camera and this is our perspective camera. This is how the orthographic camera renders. There is no perspective here. As you can see, it just looks flat, even though the positioning is the same. So the next thing we're going to do is create a GUI for our camera properties. Okay, so over here, underneath a light type dataset, this is where I'm going to create our object for our camera properties. Here's our camera data object. So here we will have our field of view, and then we will have the near clip plane, far clip plane, and then we'll have the orth camera divider. Now this will work something similar to our field of view, even though it's not quite the same. So this is what we'll be able to play around with our GUI, just to see what these properties are actually doing in the camera. And so next, I will create a camera folder. So this will be called camera properties. And then we'll add our first property, which will be our camera's field of view. And then we'll add the near clip plane. And next will be our far clip plane. And then we'll add our orthographic camera divider. Now the orthographic camera divider, remember, is this value over here, this one. So that's what we are using over here. So here I just gave it a fixed value of 100, but in our GUI you will see how I will set this is the value that I'm going to be using. This setup you are familiar with, so I'm not doing anything new. So I'm just adding camera data. I'm just using the camera data. This is where we'll retrieve all our properties, and I will use field of view, and this is the minimum and maximum value. So what I will do is, when the value changes, then I will go to our camera's field of view and I will assign it the value. Okay, so that's all that is doing. So this is all within your scope of knowledge at this point. So now let's have a look at what that does. So we add our point light. Let's go to our camera value. So we see the camera's field of view. This is our perspective camera. So this is what the field of view does. So it just determines how much the object is rendered on our camera. So when it's close, then it takes over the camera. It almost looks like an orthographic camera, but it's not still, because you can still see the perspective. And so this is the near clip plane. So that's what that does. So it means that for our orthographic camera, at a distance of 10, it's already clipping. Then for our perspective, at the distance of almost 60, it's already clipping. Okay, well, it starts clipping at 49. And so the far clip plane is similar. With the far already at 49, it starts clipping. Okay, I need to fix that. I think I put in the wrong value. I need to make that 1000. You see the far clip plane. So at 50, it's already clipping for our perspective camera. And at 16, it's already clipping for our orthographic camera. Okay, so when we look at these values, you can see here I've got a function called execute divider. Now this is not set up yet, so I need to create this, because that's how we're gonna change the value of our orthographic camera divider. So I'm just gonna move up. So I'm just gonna put it here just before our camera data object. This is where I'm gonna set it up. So in here, then I will influence the orthographic camera's left. I will say it is equals to width divided by minus value. So whatever value we get from our slider on our GUI, so it will divide it by that negative value. So the right, I will divide it by a positive value. Then the top, I will do the same thing. Orthographic camera height will be divided by the value, and bottom, same thing. It will be divided by a negative value. Okay, so this is what that does. So every time we change the value, it will execute this function. Okay, as you can see, so that's what that does. But unlike the field of view, where you can actually see the perspective, here it's all flat. It's just, you don't really see the background much. It is quite fixed. Okay, so in a nutshell, this is how our perspective camera and orthographic camera work. So this would probably be a good setup for a map. You know, if you're have a game set up like a first person shooter or something like that, then you could have the orthographic camera like here in the corner as a map so that you can see where you're moving in your 3D space. So that's what that would be useful for. So these are the two cameras. With all of that said, I'd say love and peace. This was the last one. So yeah, I hope you enjoy it. Thank you.